In New Mexico's blinding white sands, a set of ancient human footprints surfaced, so old they shattered the timeline experts trusted for decades. The official story claimed America's first settlers arrived 13,000 years ago, marching behind herds through an ice-free corridor. Yet here, pressed deep into Ice Age mud, are undeniable tracks from families walking the continent nearly 10,000 years before that, at the height of the glaciers. If the Clovis First model never fit, then who really were the first Americans, and how did they cross a frozen world? The answer begins with a discovery that rewrites everything. In 2009, while surveying the stark gypsum flats of White Sands National Park, park biologist David Bustos noticed faint, dark impressions trailing across the blinding white ground. At first, they looked like animal tracks, but as Bustos examined them more closely, the outline of a human foot became unmistakable. He began to dig test pits, revealing not just a single set, but a dense tangle of footprints pressed into ancient lakebed sediments, evidence of people young and old moving across what was once the muddy shoreline of Lake Otero. Some prints showed the broad, flat shape of bare feet, others the smaller, rounder marks of children. In places, tracks overlapped, forming layered snapshots of families and groups passing through over generations. The gypsum substrate, soft and damp during the last ice age, captured every step in remarkable detail. To Bustos, the diversity was striking. Adults striding with purpose, children darting in clusters, teenagers leaving longer, confident strides. He documented thousands of tracks, each one a direct physical link to Ice Age people living in this landscape. The impressions ran for hundreds of meters, sometimes in parallel, sometimes crossing paths with the deep prints of mammoths or the clawed marks of ground sloths. This was not a single fleeting visit, but a record of repeated human presence preserved in the layered sediments beneath the desert surface. Each footprint, pressed into the ancient mud, offered a glimpse into lives lived at the edge of a vanished lake, waiting for their story to be uncovered. For much of the 20th century, textbooks held firm to a single story about the first Americans. According to this doctrine, no human set foot in the Americas before the Clovis people, big game hunters who arrived around 13,000 years ago. The evidence seemed clear. Clovis sites, scattered from New Mexico to Montana, revealed a toolkit of fluted spear points, elegant and deadly, perfect for bringing down mammoths and bison. These tools appeared everywhere, in consistent layers, and always above unbroken beds of ancient soil. Archaeologists saw this pattern as proof that Clovis culture represented the continent's original settlers. The theory fit the times. It matched the idea of a migration out of Siberia, crossing the Bering Land Bridge during the last ice age, and funneled south through an ice-free corridor that opened between the massive Laurentide and Cordilleran ice sheets. This corridor, a narrow strip of tundra and grassland, was supposed to be the only route into the heart of North America. For decades, any claim of an earlier human presence was dismissed as contamination, misinterpretation, or wishful thinking. Sites that hinted at older dates, Monteverde in Chile, Paisley Caves in Oregon, or Cooper's Ferry in Idaho, were met with skepticism or outright rejection. The Clovis First model became more than a theory. It was the gatekeeper for American prehistory, shaping which discoveries would be believed and which would be ignored. If the White Sands footprints truly dated to 21,000 years ago or more, they would not just challenge a timeline, they would overturn the foundation of an entire scientific worldview. Radiocarbon dating on tiny seeds from the ancient lakebed delivered a result that few expected. The footprints at White Sands were pressed into mud between 21,000 and 23,000 years ago. In the world of American archaeology, this number landed like a thunderclap. Almost immediately, a chorus of doubt rose from researchers across the globe. The seeds belonged to Rupia serosa, an aquatic plant that draws carbon not from the air but from dissolved minerals in lake water. In closed basin lakes, this can create a hidden trap. Old carbon locked in groundwater and limestone can make anything that grows there seem far older than it truly is. Critics warned that the so-called freshwater reservoir effect could inflate radiocarbon ages by thousands of years, pushing the footprints into a distant past they never actually reached. Some pointed to other lakes where aquatic plants gave dates out of order or impossibly ancient. Others questioned whether robust seeds might have washed in from older sediments, settling into younger layers and setting a false upper limit. The debate grew heated. Some experts suggested that once these complications were accounted for, the real age of the prints might be far younger, perhaps only 15,000 or 16,000 years old, in line with other early sites. Just like that, the case for Ice Age humans in New Mexico looked fragile, balanced on the chemistry of a single plant and the unseen pathways of ancient carbon. United States Geological Survey. Geologists, faced with fierce skepticism, returned to the White Sands site determined to resolve the dating controversy once and for all. Their approach was methodical. If critics doubted the radiocarbon ages from aquatic seeds, then every possible line of evidence would be tested independently and in parallel. The first step was to extract terrestrial pollen from the exact same sediment layers as the original seeds. Using flow cytometry, they isolated tens of thousands of conifer pollen grains, each carrying carbon fixed from the ancient Ice Age atmosphere, not from lake water. Radiocarbon dating on these pollen samples, done in a separate, accredited laboratory, produced ages nearly identical to the original seed results. The numbers matched, even after rigorous blank corrections for modern contamination. To remove any lingering doubt, the team turned to a completely different method, optically stimulated luminescence, called OSL. This technique measures the last time quartz grains in the sediment were exposed to sunlight. Quartz from just below the footprint layers gave a minimum burial age of over 21,000 years, in perfect agreement with both seed and pollen dates. 3 independent clocks, each run on different materials, each analyzed in different laboratories, converged on the same answer. In 2023, the team published their findings, laying out a timeline locked in by radiocarbon, luminescence, and stratigraphic order. The debate shifted. The evidence was now too consistent to ignore. The footprints at White Sands were pressed into the mud during the height of the last ice age, their age confirmed beyond reasonable doubt. A line of footprints stretches across what was once the muddy edge of Lake Otero, pressed deep and wide as if carrying a burden. Stride analysis shows the walker, likely a woman or adolescent boy, moved north with a heavy load, the prints broadening and twisting slightly with each step. Twice along the mile-long journey, the tracks pause and a smaller set appears, hinting at a child being set down and then lifted again. On the return, the same adult walks alone, the stride lengthening and the pace quickening, the prints narrowing without the extra weight. Nearby, the clawed impressions of a giant ground sloth arc in a defensive circle, rearing up as if startled by the human presence. Moments later, the deep, round craters of a mammoth's feet cross the path, trampling the soft mud where people had just walked. These layered tracks capture a day in Ice Age life, caregivers, children, and giants sharing the shoreline, each leaving their mark in the glacial mud. The path into the Americas was never a straight line through the heart of the continent. During the last glacial maximum, 2 massive ice sheets sealed off the interior, creating a frozen wall that stretched from the Atlantic to the Pacific. Environmental DNA from ancient lake beds in Alberta confirms the so-called icy free corridor was lifeless mud until 12,600 years ago, thousands of years after the White Sands footprints were pressed into the ground. With the interior blocked, attention turns to the Pacific. At that time, sea levels were 400 feet lower, exposing a continuous coastline rich with kelp forests, fish, and marine mammals. This kelp highway offered a thriving ecosystem and a navigable route, linking Beringia to the far south. The coast became the main gateway, not the interior corridor. Genetic studies show the ancestors of Native Americans split from their Asian relatives between 25,000 and 23,000 years ago, matching the timeline suggested by the oldest sites like Monteverde in Chile and Cooper's Ferry in Idaho. The evidence now points to the coast as the primary route into the Americas. Today, every new discovery challenges the boundaries of what we know about our origins. As science uncovers deeper layers beneath our feet, the story of who arrived first and how remains open. The past is still speaking. The real question is, are we ready to listen?